For today's episode, we'll be covering Deadpool physics. However, let's not forget, Deadpool is a superhero, so he'll end up just fine. But it doesn't mean the same for you. This is Steam Room, and it starts right now. So today, for those of you superhero and physics fans out there, we're going to be covering one of your favorite lovable, fourth wall breaking, wisecracking superheroes, Deadpool. Now, after watching the film recently, I was blown away by one of these scenes and its physics. Check it out.
Maximum effort.
Now, action-wise, this scene is pretty incredible, let's not lie. However, for a physicist, this scene brings up an interesting case. Now, would Deadpool actually have made that fall? In order to find that out, we have to look at a concept called kinematics. For those of you unfamiliar with this concept, kinematics is the branch of mechanics that deals with pure motion without reference to the masses or forces involved in it. We can use the following formula to solve for it. The final position equals the initial position plus the starting velocity multiplied by the time plus 1/2 of the acceleration multiplied by the time squared. And also, note that this formula ignores air resistance. Now, we will be using this formula twice. One time for the vertical direction, which is the direction Deadpool will be falling in, and another time for the horizontal direction, which will be the direction the car will be moving in. To solve for the time where the 2 points meet, we'll be gathering the time when Deadpool reaches the car, and the time it takes for the car's sunroof to be under Deadpool. The information we'll need to solve for Deadpool's fall is this: the acceleration due to gravity, Deadpool's starting position, his initial velocity, which will be 0 in the laws of free fall, and the end position, which will be the top of the car's sunroof. Then for the car, we need the distance the car's sunroof will be from Deadpool horizontally, the initial speed, and the final position, which will be 0. Piecing this information together and plugging it into our equation, we can use it to find the time the car will be under Deadpool and the range of time Deadpool has to successfully land through the sunroof. If he's too early or too late, he'll have a rude awakening with the concrete. But if he falls slightly late, he will most likely face decapitation or being split in half by the sunroof. When we discover the time it takes for Deadpool to reach this final position, it seems as though even when considering air resistance, Deadpool reaches the ground before the car's arrival. So, in conclusion, it looks like our merc with a mouth is going to reach the ground in a big splat. This has been Steam Room. I'm your host, Professor Q. See you next time.